Okay, we're talking trapeziums on with the video.
And this is going slow again. Thank you, Desmond.
You should just stop the video and start again. Yeah. I'd like to see.
Right, area of a trapezium then. So one thing is, you've got a formula which is area is a half or divide by 2, and it's 1/2 of, is it A plus B times by H, or as you said, it's A plus B times H divide by 2. Okay, the computer's going slow. Either one means the same thing, doesn't it? Because timesing by 1/2 is the same as dividing by 2. So the question is, where does that come from? What does a trapezium look like? So I think in the book you've got trapezium. The properties of a trapezium are that it must have 2 parallel sides, whereas a parallelogram has 2 pairs of parallel sides. A trapezium only has 1 pair of parallel sides. So the trapezium here, these other 2 sides are not parallel, and that leads us to where some people get a bit confused. Okay. Now, again, where does all the formula come from though? So if I say to you that the lengths we all know, we'll call one of the parallel sides A. By the way, Cameron, show Cameron your booklet so he knows what he's doing. Which page he's got to put it on, because you won't know. So this one's A. This length is B, so the bottom one's B. It doesn't actually matter which way round it is. Okay? And we want to know how to do the area. So what we do is this. There is a couple of ways to think about it, but the way that explains this formula is to do this. I'm going to take exactly the same trapezium, just like I did with a triangle to make the parallelogram, and I'm going to stick another one of it, and I know this might not be exactly the same, but I'm going to try my best. Okay. Yeah, I'm going to stick another one that's exactly the same on the end. So they're 2 exactly the same trapeziums. All right? Got space up there. I think actually if your booklet's together, you have the different colour page above it. You can put your booklet together. All right. What do you notice about that trapezium? Now, it's a parallelogram. So what is the formula for the area of a parallelogram again? That's on your other page. Desmond.
It is area equals base times height.
Just base times height, yeah? Where height is the... Good, perpendicular height. So, to work out the area of this parallelogram, I need to know the base. So what is the length of the base of this entire parallelogram?
It's B plus
Ava? B plus A, because this length is the same as that length. So that's A there, and that's B. So the base of this parallelogram is B plus A, or A plus B, and that's up here, look, A plus B. All right? What do you think H is? H is the height, and again, it's got to be the perpendicular height. So we've got to make sure it's at right angles and it's the height. Okay? And why do you think it's divide by 2? Ava? Exactly. Exactly that. You double it up to make the parallelogram, you work out the parallelogram, but we only want half of it. Okay? So that's where that formula comes from. Makes sense, right? Easy enough. Yeah. Well, yes. but it's a multiplier, isn't it? Because we multiply it by h rather than add it on. Now, so that's easy enough. Do you all understand where the formula, how you would use it, and that kind of thing? Again, like a parallelogram and a triangle, what should you not fall into the trap of using? The side length. This length here is not... in a question, they might give it to you, but now you're getting into a phase where not every number you're given needs to be used. So if we have to work it out. Now, what I thought was it would be useful for our little notebook would be some different examples of trapezium, because that's what most people think a trapezium looks like. If I ask you to draw a trapezium, but actually a trapezium can also look like this, where you actually sort of start with, yeah, exactly. As long as these two sides are not parallel, so it could look like that, and it can have 90-degree angles at the end. In that situation, this length is the same as the height. Now again, this could be A, this could be B. This length here would be the height. And you'll notice that the height is not high. It's along the ground. So you've got to kind of sort of distance yourself a little bit from what you understand the words base and height actually mean in reality, and think about, well, that shape could be drawn in. Imagine you're in space. Yeah, you're floating around in space. Which direction is up? Whichever one you want. Yeah? Well, it's only if you're within a field of gravity, isn't it? That up is away from gravity, against it, and down is with gravity. Yeah, because actually, up on the southern hemisphere, if you're looking at the planet from a distance, up on the North Pole is down on the South Pole. But as you walk around the planet, unless you're a flat earth person, don't say you are, because none of you are like that. Right, so it could be like that. Just another option is also your trapezium could be almost a parallelogram, but not quite. Because this side is parallel to that one, but those two aren't actually parallel. So again, people would look at that and go, oh, that's not a trapezium. All right? But it is. I've almost drawn, from my angle, I've almost drawn a different shape there, but it's not quite, so I'm all right.
A rhomb.
Not a rhombus. A kite, yeah. Yeah. Not quite though, not quite.
Almost a rhombus too, right?
So again, no, it's not. It's not a. Yeah, that's what we were looking at. It's almost like you would expect a parallelogram to look. But that's what I'm trying to avoid here, is to give you different examples of what a trapezium could look like, so you don't get thrown by the fact that the sides are just slightly different directions. So again. And I will say again, A could be the longer one, and B could be the shorter one. And where's the height? Yeah, go across. Sorry, it should be straight, but that would be the height, wouldn't it? Right? So you've got different versions of a trapezium there. Now again, there is another way people have done trapezium, so just in case you've done this before, you don't have to add this one into your notes, but it's up to you, because it doesn't really match with the formula so easily. Sometimes people have done trapeziums and they've explained trapeziums by starting with this trapezium here. Alright, maybe you've done this one before, and they chop that off to make a rectangle, and then they move it to the other side, okay, and turn it upside down. Or no, sorry, they chop it and they do it as a triangle and a rectangle. I was thinking of a parallelogram where you chop it off, right?
Let's talk it like that, except with one in this color.
Yeah, the parallelogram one. So actually, if I go up to the one that you did before, the parallelogram. Look, so what some people will do is say, if I chop that off and put it onto this side, it looks like a rectangle, which is fine because you can work out the area in that way. But the formulae that are given and that you have in your formula books and things like that, I've done it how they are created, how they're based. Okay, so we've got that, and you've now got the area of a trapezium and what different trapezium look like. All right.